Every night, your brain expects something. Not entertainment, not stimulation, not productivity. It expects sleep. For billions of years of evolution, the brain has followed a rhythm: wake, rest, restore. When that rhythm is broken, something subtle begins to change. At first, it feels simple. You feel tired, maybe a little slower, maybe a little foggy. But sleep loss is not just fatigue. It is a biological disturbance that spreads through the brain like ripples through water. To understand what happens when you don't sleep, we need to begin with the first night. After about 16 hours of wakefulness, the brain begins building sleep pressure. This pressure is caused by a molecule called adenosine. Adenosine accumulates in the brain throughout the day. The longer you stay awake, the more adenosine builds. Its purpose is simple. It tells your brain that it is time to rest. When you sleep, adenosine is cleared, the pressure resets, but if you remain awake, the pressure continues to rise. At first, your brain compensates. You may drink coffee. Caffeine temporarily blocks adenosine receptors. You feel alert again, but the molecule itself is still there. The pressure is only hidden, not removed. Eventually, the brain begins to struggle. The first major system affected is attention. The prefrontal cortex, located at the front of the brain, is responsible for focus, planning, and decision-making. This region is extremely sensitive to sleep loss. Without sleep, its activity begins to decrease. You may notice small changes. You reread the same sentence twice. You lose your train of thought. You forget why you opened a web page. These are not random lapses. Are signs that the brain's executive center is under strain. But attention is only the beginning. Sleep deprivation also affects memory. During sleep, the hippocampus and the cortex communicate constantly. Memories from the day are replayed and stabilized. Information moves from short-term storage into long-term networks. Without sleep, this process cannot occur properly. Imagine trying to save a document, but the computer shuts down before the file is written. The information exists temporarily, but it never becomes permanent. This is what happens to memories when sleep is restricted. Learning becomes less efficient, retention weakens, even creativity begins to decline. Sleep also regulates emotional balance. The amygdala, the brain's emotional alarm center, becomes more reactive when sleep is lost. At the same time, the prefrontal cortex becomes less able to regulate those reactions. The result is emotional imbalance. Small frustrations feel larger. Patience decreases. Stress feels more intense. Studies have shown that sleep-deprived brains can show up to 60% greater emotional reactivity to negative stimuli. The brain becomes more sensitive to threat. But sleep loss does not only affect how you feel, it also affects how your brain cleans itself. During deep sleep, the brain activates something called the glymphatic system. This system flushes metabolic waste from brain tissue. Cerebrospinal fluid moves through the spaces between neurons, carrying away toxins that accumulate during wakefulness. One of the substances cleared during this process is beta, a protein associated with neurodegenerative diseases. When sleep is shortened, this cleaning process becomes less efficient. Waste remains longer inside the brain. Over time, the accumulation of metabolic byproducts may increase neurological strain. The brain depends on sleep not only for rest, but for maintenance. And maintenance cannot occur while the brain is fully awake. Sleep deprivation also affects how neurons communicate. Normally, neurons transmit signals with precise timing, but when sleep is restricted, communication becomes less stable. Signals may weaken or become delayed. In some cases, neurons briefly enter sleep-like states, even while the person remains awake. These brief shutdowns are called microsleeps. They may last only a fraction of a second, but during that moment, the brain is effectively offline. If you are driving, that moment matters. If you are operating machinery, it matters even more. Sleep deprivation is one of the leading contributors to attention-related accidents worldwide. And yet, many people underestimate its effects. This is another strange feature of sleep loss. As the brain becomes impaired, its ability to recognize impairment decreases. Sleep-deprived individuals often believe they are performing normally, even when objective testing shows significant decline. The brain loses its own self-awareness. This is why sleep deprivation can be dangerous. It reduces performance while hiding the reduction but the brain continues trying to compensate. Certain regions become overactive in an attempt to maintain function. The brain recruits additional neural networks to perform simple tasks. It is like a small team suddenly doing the work of a much larger one. For a short time, this strategy works, but it is inefficient, and the longer sleep is delayed, the harder the brain must work just to maintain basic performance. Eventually, the system begins to destabilize. Reaction time slows. Memory errors increase. Mood regulation weakens. The brain becomes less coordinated. After about 24 hours without sleep, cognitive performance can resemble that of someone with significant alcohol intoxication. Decision-making becomes impulsive. Risk evaluation weakens. Judgment becomes unreliable. Yet, the brain still attempts to function, because wakefulness is only half of the biological rhythm. Sleep is the other half. The brain is designed to cycle between them. When one side of that cycle disappears, the system strains, but the brain also has remarkable resilience. When sleep finally occurs, recovery begins immediately. Deep sleep intensifies. Slow wave activity increases. The brain prioritizes. Restoration. Memory consolidation resumes. Waste clearance improves. Emotional circuits rebalance. This is why sleep after deprivation often feels unusually deep. The brain is repairing the imbalance created by prolonged wakefulness, but recovery takes time. One long night of sleep does not erase the effects of chronic restriction. Sleep debt accumulates gradually. The brain repays that debt slowly. This is why consistent sleep matters more than occasional recovery. Your brain is not designed for endless wakefulness. It is designed for rhythm. Wake. Sleep. Restore. Repeat. Every time that rhythm is respected, the brain functions more clearly. Every time it is disrupted, strain increases. Sleep is not simply the absence of wakefulness. It is an active biological process that protects the brain. And when the brain is denied that process, even for a short time, the consequences begin almost immediately. Not dramatically, not all at once, but quietly, system by system, the brain begins to lose its balance until sleep returns. And with it, the restoration the brain has been waiting for all along. But there is another change that happens in the brain when sleep is missing. Communication between brain regions begins to lose efficiency. Normally, different parts of the brain coordinate with remarkable precision. Networks responsible for attention, memory, and decision-making synchronize their activity in stable patterns. Sleep helps maintain that coordination. Without it, those patterns begin to drift. Signals become weaker. Timing becomes less precise. Connections that normally work together start operating out of sync. This is why complex thinking becomes harder after sleep loss. Tasks that require planning, reasoning, or creativity begin to feel unusually difficult. The brain is still working, but the system is less organized. Sleep also plays a role in resetting synaptic strength. Throughout the day, experiences strengthen connections between neurons. If those connections continued strengthening indefinitely, the brain would become overloaded with noise. Sleep solves this problem. During deep sleep, many synapses are selectively weakened. Important connections remain strong, while unnecessary ones are reduced. This process keeps the brain efficient. Without sleep, that reset does not happen properly. Neural networks become crowded with excess activity. Clarity decreases. Focus becomes harder to sustain. In a sense, sleep is not only rest for the brain, that it is recalibration. Every night, the brain reorganizes itself, restoring balance between activity and recovery. When sleep is missing, that balance slowly begins to tilt, not instantly, not dramatically, but enough that the brain starts operating below its true potential. And the longer sleep is delayed, the more the brain waits for the restoration it was designed to receive. There is also an important shift in how the brain manages energy. The brain represents only a small percentage of the body's weight, yet it consumes a large portion of the body's energy. Neurons require a constant supply of oxygen and glucose to maintain electrical signaling. Sleep helps regulate how that energy is used. When sleep is restricted, the brain must work harder to maintain basic functions. Some regions increase their activity to compensate for weaker performance elsewhere. This temporary strategy helps maintain wakefulness, but it is inefficient. It is like running a machine beyond its normal operating limits. For a short time, the system continues, but strain begins to accumulate. Energy regulation becomes less stable. Mental fatigue appears. Sooner. Tasks that once felt simple begin to require more effort. The brain is attempting to maintain balance without the restoration it expects each night. Over time, this imbalance affects motivation as well. Sleep deprived brains show altered activity in reward circuits. Activities that once felt engaging may feel less satisfying. At the same time, the brain may seek quick stimulation, sugar, scrolling, distraction, in an attempt to compensate for low energy. These changes are subtle at first, but they influence daily behavior. It is time to rest. Asterisk.